Hello, everyone. Welcome to another webinar. My name is Rich Martin, Senior Technical Marketing Engineer at Itential. And today's demo and topic is Advanced Data Transformation Techniques. So let's take a look at the demo and the main points we'll be going over today and some of the integrations and the systems we'll be using. So part of this demo is to illustrate some advanced techniques that we use in our data transformation feature. Now, we've covered some of this and not only in some previous webinars, but also in the data transformation series. But really, we didn't spend a whole lot of time going through kind of the bits and pieces of how this works and maybe some alternative ways of accomplishing certain tasks within data transformation. So that's the purpose of this. So what I want to do here is really take a look at some of the work we've done before, expand that a little bit more, as at the same time introducing some new topics and some more advanced things that if you're a user of the platform, you can start to build and try out. And if you're coming new to the platform for the first time, things that you can understand and know that the capabilities are within data transformations. So some of the things we'll be talking about is using multiple source inputs and input schemas in a data transformation. I look at this as more of how can I gather all my data that I need in order to accomplish a particular task. We'll also talk about formatting human readable output and some of the functions and ways to do that, and some of the things to look at when you're doing that. So, for instance, if we're creating human readable output from API data from API calls, what are the functions that really are helpful for that? And then what are the things we need to be aware of as I'm passing that data in a human readable format to another application or another system? We'll talk about different methods of string manipulation within a data transformation, because this happens a lot. We'll also get into a little bit of math and numers and addition as well. We'll talk about using JSON queries and extracting data, especially along the lines of our last demonstration here, where we'll spend some time in the transformation side of things, looking at building logic with conditionals. This won't be as much about automation as it is transformation. This is going to be more focused on that. But of course, data transformation is a critical part of any automation. So for that, we will be using integrations from data forms, from NetBox, from Slack, from ServiceNow. These are the most common systems that we integrate with, because these are the most common systems that we see our users and prospective customers asking about. That being said, we do integrations with all kinds of systems, so it's certainly not limited to that. And then finally, let's take a look at some of the overview of two automations that we'll be covering today. And then we'll spend the latter part of today's session just in the JST, or the data transformation designer itself, and showing you some advanced things that of the topics that I just talked about. But in the workflows here, we will cover kind of a perennial thing. Like every network engineer wants to automate certain work, right? Making changes to a network device, for instance. And so where does that data come from? I always try to tell people, think about where the data comes from. It's rarely from a single source. In this case, the data is going to come from some data that gets input through a form that could just as easily be a trouble ticket or a change request ticket. We need to get some data from NetBox, which is our IPAM system in this case. The key here is transforming that data. So now we've got to take the data in the format that it's given to us from those two sources, transform it, and turn it into something that's now usable later in the automation. In this case, the end task the focus that we're really trying to do is generate some CLI commands that could be passed to a network device to make a change to that device. In the second one, we'll open a ServiceNow change request, and we'll take a look at the data that gets responded back from that request when we open a ticket, and how do we extract the needed pieces for that, so that not only can we use that for the ServiceNow update, because as a ticket's created, it's got to be given a unique name that gets referenced later on, but what other what other elements in our automation are going to reference that. So we're going to focus on doing a transformation now that can notify an entire group on the Slack channel when a ticket gets open. And this is a very straightforward case, but what we're really looking here is the data transformation steps necessary to do all of that. And again, this is all about creating human readable output in the format that Slack requires for it. So we'll take a look at that, and then we'll spend the remaining time in today's webinar just looking and building real time some data transformations to show you some of the breadth and the width of the tools that are available to you. So with that, let me switch over to my screen share, and we'll get started. Fantastic. Okay, so what we're looking at is our first demonstration. So if you remember just a moment ago, I talked about multiple sources of truth. So if you as a network engineer were about to make a change to a network device, let's say a router, in this case, we'll define a new interface. What data do I need? So this helps to create the context to understand where our data comes from. So when we're building automations, data can come from multiple sources, and it usually does. If I am going to define a brand new network interface, I need an IP address. That should come from an IPAM system, ideally, because that's something we can automate with, and we can get a new IP address that's unused, and now apply it to that particular network interface. But I need to know what device I'm going to make the change on, and I need to know what interface at a minimum, and probably a description of some sort so that we can update that interface with the proper description names. So at this point, I'm going to develop this with two data sources. One that's going to come from a form input. Again, this is just a simple way of doing it. This could come from a ticket, right? The ticket could have the information, like in ServiceNow or Jira, that we need for the device and the interface and the port description. But in this case, we'll get it from an input. We'll get the IP address from NetBox as our IPAM. And ultimately, we are going to take that data and format it into something that we can identify as the proper CLI commands to make that change. But all of that magic happens within this step right here. This JST is the data transformation within our platform that we would build to take the data from both of these sources and then generate the, I guess you could say, human readable output or machine formatted output in the correct CLI context. So with that, let's go ahead and I've given you the overview. Let's go ahead and run this, and then we can take a look at the data that gets generated so that when we drop into the JST itself and look at the transformation steps, that makes a little more sense. So I can start it from here, and we can view the job as it's running. And the first step here is it's asking and it's waiting for us to get data from a form. So anytime you see a blue task here in a workflow in our platform, that is something that's requiring human input. In this case, I've got to enter some data for a task. So if I click on here, I can work that task. It's going to pop up the data that it's requesting. So I already have it pre-filled out. For the router name is this device, core ATL0. The interface is loopback 301. And for this description, we will just use webinar. And when I click confirm, it's going to move on to the next step. So I filled out the source of data from that we're going to need for in our transformation to generate the CLI commands. The next step was to get the IP address from NetBox. So let's take a look at the output of that. So I just filled this out. If I go here to variables, and let me expand this a bit so you can see here. The outgoing data that came from this particular task, again, this is our first source of data, outputted a JSON object that has these three fields defined: router, interface, and description, as strings because they're double quoted. So they're defined as strings. And this is the information we need, right? This is one half of the information, or at least one part of the information we need. We need the router, we need the interface, we need the description. So the other part of that now is going to come from this step. So we can take a look at the variables from there. So now that's going to output some variables, but you'll notice it's outputting a ton of information here. Right? Look at all of this. So this comes back from the request in NetBox to provide a new IP address. And we can see here, this particular field address is what we're looking for. At least it does contain the data we're looking for, but perhaps not in the right format. And this is key. This is critical. Data transformations are going to be used to manipulate that data or transform it into what we need it to look like. So these systems don't, by default, provide that data in the format we need. So we have to make those changes, and that's what the transformation does. So at least we're getting the data. So now these two sources will be used in this transformation. So as you see here, this transformation is already run. We're at this step here where it's waiting for me to view the data. I did that so that we could take a look at the output of the JST, and then we'll jump into the JST, that transformation itself. So these two data sources went into this transformation. That transformation now manipulated the data, transformed it into the format we need in order to pass it to a CLI router to make the change. So if I click on this task now, and since it's blue, it's waiting for us to take a look. So this is an intentional pause I put into here, just so we could see the output that our transformation generated. And this, if you're a network engineer, then this looks exactly like what you would type on a command line. So in this case, we've taken data that we need in order to generate this. And this is our focus. This is the focus of this particular task. I need data so that I can format it into this particular way so that it can be used to pass on to a router. Now, the key here is, how do we get the data that came from our sources into the right format? And that's where we kind of peek into the world of the transformation. So here we're actually looking at the transformation that turns all of that data from those two sources into the CLI format. And this is, again, the keys that you need to understand when you build these transformations is all of these methods. And that's what we'll be going over today and giving you some tips and some ways to do that. But let's start from our first data source, at least the way it's defined here. So the first data source, if you remember, was this form that popped up that was the user input from that turned into an output that became fed into this JST. So that was one of the sources. And remember, in that, I defined the router name, the interface, and the description. 3 critical pieces of information that we need to generate the CLI commands to pass to a router. But we are also missing the actual IP address, and that came from the NetBox data source. So from the form, because I defined that, the data that was returned is very straightforward. Actually, all the fields that we need are there. When you define a form like that, you have control over the data that you're requesting from a user and the data that gets passed in to a transformation or even another task. But when you're doing an API call to a different system, it's going to reply back with a lot more data. So the schema that comes in from NetBox matches the data that it's going to return to us when we make that call. And as you can see, we looked at the live data, but you can see the schema for it provides a lot of information. Most of it, at least for our purposes here, aren't really required. But the nice thing about it is, once that schema is defined for our input, it makes it very easy now to map that information out. So in this case, I'm taking that IP address and I'm mapping it out. Now we're going into a couple of extra methods here, because remember what I said, data from NetBox isn't going to be formatted in the right way. And one of the key things here is the way that the data is formatted coming out of NetBox. The net mask itself is not an independent variable, and it's part of the address that's returned, and it's in the CIDR or CIDR format, and it's not in the dotted quad net mask. And if I'm going to push CLI changes into a router using this data, I have to convert it, and that's the key here. I have to convert this. So there's a couple of things going on here, and we can take a look at this step by step, because one of the great things about this, our transformation designer here, is that it gives us the ability to troubleshoot and kind of walk through this and in real time without having to run an automation. So as we defined and created the incoming schemas, we can do that from real data. I can literally copy and paste the output of that NetBox command and create the incoming schema along with the example data that's there. We've done that in the past by doing an infer of the schema. I can show that to you right now. If you paste live data here, you can click Infer Schema, and it will actually generate all this along with the example data that was passed to it from what was output from a live call through an automation. That's great, because now we can start to test and run this in the transformation designer so that we can kind of make sure all of our data is being manipulated in the right format before we even have to run a live automation. So in this case, I have already built out, but I want to step through it because later on we'll build things out live. So one of the things that we did see, and we can see this again, if I go to the output of the NetBox call, if I go to variables here, the output again, this is the address field in that JSON object. And this is the format that it's put the IP address and net mask in. So going back to our transformation, here's the address field. And we know that we need to parse out the IP address and ideally the net mask. So that's where a lot of these functions come in. So this is coming out as a string. So understanding that, your variable types here, this is a string, so that we need to act upon it with methods that are based off of string too. And in this case, there's several of them, and we'll talk about string manipulation methods in different ways. But I'm using split here because one of the things I know from working with the NetBox API is that when it returns an address, it always returns it in that format if on a successful call to the IPAM. So because of that, I know that the format is going to include a separator that is a /. So it's going to be a dotted quad IP / and then the net mask and CIDR. So using the split method here, which is located under string and split, I can use this, and I can always click here, hover here, and click here to get even more information and documentation. But what this does is it takes a string, you give it a separator. It could be a character or multiple characters as a string, and it's going to break up that initial string based off of the separator character, and then return it. You can see here as an array. So an array is going to have strings here is going to have multiple elements potentially. And in this case, we know because of the data format for the IP address, it's going to be two elements. The first element, which is element 0, is going to be the IP address. And the second element, which is element 1, is going to be the net mask and CIDR format, with the separator being the / there. So that's what the split method does here. So I'm feeding it as the input, the string that needs to be split, and giving it the separator statically, manually. I just type it right here. The output of that is going to output an array once that function or that method is done, rather. And then we have to tell which index of the array we want to pass along. And in this case, index 0, because we want the IP address. So now these methods have allowed us to extract from the NetBox call the data we need to accomplish the end task. So that was one of our sources as well. We remember the other source that we had was from the form. So now we have all of the sources of data we need. So let's take a look at template literal. Template literal is going to be kind of your best friend in a lot of ways within building data transformations, because it's a very easy way of generating, well, for the most part, for me, more human readable input in a very direct manner. So the way template literals work is, if I click here, I can quite literally type in exactly the commands that I want. And I can now define variables by using this format here, $, and then within the curly braces, the name of a variable that I want to define and replace in this template. So this becomes a template, free form. I get to type in whatever I want to match the format that I need. Again, and we'll get to why we have to understand what the end result is, or the focus of the system, because we have to manipulate the data in the right format for that particular system. So in this case, the focus is, how do I generate CLI commands? And how do I now take the data that we've extracted from our input from NetBox and the form, and how do I create variables and make a template out of this so that I can have this particular method replace those variables in the right order with the right information to generate the CLI commands that's the right format in order to make a change on a device. So that's what this is doing. So literally typing interface just like we would on the CLI command. If we do this in Notepad as network engineers all the time, replacing this variable. So we're going to define this variable interface name, right, for our first line. And then we need to set the IP address. So IP space address, the IP address and the net mask are set as variables. And then description, that's where our port description comes. So that is our template that we've created here. And now once that happens, we have these variables that become available to us to map into. So Remember from NetBox, we had to do some manipulation of that data. So the output of that now is going to be the IP address, which now gets mapped to the IP address field that we defined in the template literal for that particular variable. In this case, where is the router coming from? Well, in this case, the router is mapped directly to an independent variable called router, but the interface that needs to be made, the change made to, needs to be part of the template literal because it's part of the CLI commands. So we map that to the interface name that we created in the template, and then the description as well. Now for here, we created, remember in the template literal, we created a variable called netmask as part of the IP address line, right, which is required. And I'm statically defining this because in this case, we're creating a loopback interface, and then that loopback interface should always be 255.255.255.255, right, /32. We also have the ability to statically assign things. They don't always have to be dynamically associated. In this case, just for simplicity, I'm doing this. We'll talk about converting CIDR to dotted quad netmask notation in a moment, because those are different ways we can manipulate data. But for this case, it's just a matter of collapsing all of our data into one data transformation. And this is critical. You don't always have to do that. This makes it really nice because in a single data transformation, I can have all of the necessary information that I need so that when I define a template literal, everything that I need is already there. This could have also been done using multiple independent data transformations. As you start building out more and more automations, one of the things that you'll start to think more about is creating reusable assets. So one of the principles here is that these data transformations, not only can they be created visually so more people have the ability to create them, but once you start making transformations for processes and automations that happen quite often, like for instance, creating a ServiceNow ticket, I need to know what that new ticket ID is, right? It gets generated and passed from ServiceNow back into the automation, because in order to update that ticket, I have to refer to it. Those things happen quite a bit. So now you'll start to see, hey, if I start building data transformations as reusable objects, I don't have to keep reusing them all the time or recreating them all the time. I can use what's already been created in the situations where I'm manipulating data between two particular systems. And so that's when you start to think about, should I use multiple data sources? Should I use a single data source? How often are these data sources used together, right? Or operating one after another? And this should help you to develop some best practices for building the data transformations, how you build the data transformations, and how many multiple sources or input schemas you want to use. Because the more input schemas you use, it kind of ties back to those systems being available as data sources. And so that becomes more of a, maybe less of a reusable component the more input sources you use. So it's one of those things to think about, but the intention is always to think through, can this be reused? So because that gives us even more efficiency in the future. Okay, so multiple data transformations. If we run this, so we can run this in a test environment here. So this example data is coming from the input source examples. So it allows us to test through this. And so when I test through this, it actually gives us our output variables, router and commands here. But using this log feature here, we can actually look at it as in a method by method or step by step way. So from NetBox, our first step is to split that IP address, if you recall. So from the IP address, we're passing that as an input parameter into the split method. So if I go to split method, it will highlight it here, and it'll actually show us, first let's take a look at the arguments. So the arg values here are 10481 or 10418/24. That's coming from NetBox. So that's the first arg. The separator is the second arg. So this is the /. And then there's nothing under limit because it was not necessary here, and that's null. So at the output of that, what we've got is here. The output of that has now returned an array, just like it said it would, with two elements. First element is the IP address. The second element is the CIDR netmask, which is what we expected because that split was done at the /. It's as the separator. So our next step is the get index. Recall, we want to extract now the 10418, which is the first element in that array. So if we go here, we can take a look at this next step as the get index. It highlights it for us. It says the args here are 10418 because we're passing that array to it. The second element of the array is 24. That makes sense because that was passed from the split into the get index. And then the third arg here that it's using is the index number, which is 0. So what was the output? The output is 10418, which is the IP address. So that mapping worked great. That's exactly what we needed. So that now gets passed into this template literal. So if we go into the template literal, you can see our next step is this is where we congregate all of that data together to finally give us the end result that we're looking for, the focus of the work here for this particular task, which is to generate that those CLI commands. So what are the arguments here? We defined in the template a variable called interface name. Here's the value that comes from, minimize that. That comes from here, the form data that was that's passed into this this transformation. The IP address came from the output of those string manipulation tasks, but it's in the right format now. The net mask we statically assigned, and then description also came from our form. And now the template that it renders it to is what we've defined earlier in the template literal. That's literal, that freeform text. And then the output is the format that we were looking for the CLI commands, which ultimately gives us this step right here. Let's see. Yeah, it was what I showed earlier. Yep, here we go. When I ran it live earlier. So that's what renders everything out. So again, this is why data transformation is important and how we can now leverage multiple input schemas to provide all the data we need for the task at hand. And then being able to troubleshoot this live inside the designer without having to run the automation, so that once it comes time to run the automation, you know the data is in the right format, in the right order that it needs to be. And we're also showing some simple and some more complex and advanced data manipulation tasks. So the simple one is we can always take a particular variable like router and pass it directly to an output variable router of the same type, string. So there's no manipulation needed. And a lot of times you'll see that. That's exactly what we can do. But many times you will have to go through several steps in order to get even one element of data formatted correctly so that you can use something like template literal to render it into a template that's useful for that task. So remember what the focus is of the task we're trying to do, generate CLI commands. We have to get the variables, we have to manipulate them, and then we got to put them in the right order. So that's what's going on here. Okay, so now let's move on to our second demonstration here. This is something that also comes up quite a bit. This is opening a ServiceNow change request ticket. Now, a lot of times networking teams that are getting into automation are looking at automating a task just like I did. How do I make change to a network interface or create a new network interface? But once they understand our ability to integrate with not just the networking side, but all of the IT systems and network services like IP address management, DNS, inventory, ServiceNow, Jira, whatever your ticketing system is, the light bulb goes off and says, oh, wow, that saves me a lot of time. You can automate that? Absolutely. So one of the things that comes up all the time is creating new change request tickets, and ServiceNow being probably the biggest one that we run into. So we do this all the time. And then that data from the ServiceNow ticket, again, we're going to get a lot of information from that. What we really only need in most cases is the new ticket ID, because it has to be used for a ServiceNow ticket, change request ticket update call or task, so that we can put things like, update work notes or update status, things like that in the ticket. So we always need that data, but that data also becomes useful for other systems and other tasks that you might be interested in automating to. So in this case, here's our end case. Here's our focus. When a ServiceNow ticket gets created, let's send a message to a Slack channel notifying the people in the Slack channel that the ServiceNow ticket was created. And ideally, let's make it easy for them. Let's not just give them the ticket ID, right? Where then they would have to go open up open up ServiceNow or to a tab that's already open and then query for that ticket ID and find it. Let's give them a direct link into that as well. So that's the idea here. Again, saving time, being able to do that. But the data that comes out of the ServiceNow create change request ticket doesn't get formatted directly into the format necessary for posting a message in Slack. So all the magic happens in the transformation. So when we run this, what we'll see is, again, a lot of data that gets, it's already completed because these are all API calls. There's no manual tasks like the first one where I generated a form. But we can look at the data that gets generated here. So when I create a ServiceNow ticket, here's the one thing that I really need: the ID. Now, the ID number and all of that is critical, but for, again, what is our main focus here? Our main focus, at least for this part of an automation, could be part of a bigger automation, is to extract the ID so it can be used later as a variable that can be used by another task, like updating the ticket, but also to generate the format needed so that we could post a message in Slack. So all of that's going to happen in the transformation, obviously, but it starts with the data. So even though we have a single source of information here, at least for this, we're going to pass that data on so it could be used for something else and manipulate the data so it can be used for Slack. So the transformation does that. We can take a look at now the Slack information here. We pass to it, and then we can see the response that we got the message passed into it, and it was successful. And if we look over here, this is the output of it. It just ran. This is the ServiceNow link. It formatted it in the right order, even highlighted the header here. And of course, this again is our friend template literal at work. We'll take a look at that in a second. But rendering things in the right format is critical when you think about the application that we're passing this to. If I wanted to render something, an amount of data and highlight and create links, say in ServiceNow, I'm going to have to understand the format that's required in ServiceNow to be able to do links like in notes and things like that. For Slack, it's the same thing. It's got its own way of formatting data so that we can do these kind of hyperlinks and bolds and things like that. So you still have to spend some time understanding the format for the task at hand. But template literal is the way to accomplish that. At least in my world, it's the easiest way. There are ways to do it in other methods, but template literal is usually the fastest way to do that. So with that being said, let's take a look at this transformation for this demo. So we looked at all of that data that the ServiceNow, so on this left-hand side is the information from ServiceNow that gets generated, right? So this is the format that the data is in. And of course, what we need here is the ID. That's the new ticket that gets generated. So the first thing we want to do is we want to map that ID to its own independent variable. So I call this ServiceNow change request ID. So on the outgoing schema, what I'm doing is I'm saying, just do a one-to-one, don't manipulate any data, don't make any transformation to this, because the format that it's in, that it's presented to us in from ServiceNow, is exactly the format we need for calls to ServiceNow later. So I'm going to identify that as an independent variable and map it to it. However, in order to post things to Slack, I have to follow their rules of how to do that. And again, the Slack message is going to, at least in a minimum way, when we post a message in Slack, they define, hey, we need the channel, which I'm creating here as a string, but I'm creating a new string with the channel name. And the critical piece here is the text. So if the end goal is to create a very descriptive message to get the attention of people in Slack so that they're aware of a new ticket that's been created, perhaps because we just made a change to the network, we want to format it in a way that meets the requirements of Slack, but also meets the requirements of our automation, which is to provide a link back into ServiceNow. So again, we showed you template literal earlier. This is where we can create another template, but format it for Slack. And now that becomes available to be passed into Slack with the right formatting that creates a link. So again, this is all defined in Slack. However, we get to freeform define it in template literal. So by creating a header and then surrounding it with the asterisks, what I'm doing is formatting it for Slack as a bold. Now, if I want to create an HTTP link, I have to again follow the format for Slack, but after a little research, the documentation is not hard to find. What you'll find is that if you encompass it with the less than and greater than signs and identify the link that you want to use it as as the link to click on, you use the pipe here at the end, and then you can embed the URL at the very beginning. That's the right format for Slack. So that allows us to do that. And now that I know the format for Slack in template literal, all I did was I inputted the URL for our ServiceNow instance, and I created a variable using that variable syntax here, $, and then within curly braces, and gave it a variable name, the ServiceNow ID. When I did that, it created a variable here that now can be mapped into the ServiceNow ID, which gets rendered into the template, which now gets passed back to some variables that'll be used by Slack to post the message. So again, there are times when we don't need any kind of data manipulation, and there are times where we absolutely need some data manipulation, and that can occur even within the same data transformation set. So in this case here, that's precisely what's going on. It's making those changes and rendering that out, and the end result gives us the ServiceNow link. So if we wanted to make a quick change to this, you can also do this. So I could post in without a link and reuse the same ServiceNow ID. So I could say, I can add that now to the template literal, update it, save it. Now it's going to add to that template literal so that when we go back to the demo here, I don't need to view the job because now I can look at the output. It sent that out and I've updated the template. So now it does include the ticket ID without the link. So that allows us to now use that same variable within a template literal multiple times if you want to. Once that variable is defined, you can use it as many times within the template itself because it's already been defined and mapped from another data source. Okay, so there are some techniques there to allow you to, again, format using template literal, some of the functionality and flexibility of template literal. I always think of it in terms of building more human readable formats, but in our first case, it was really more router CLI formats, but even that's more human readable. But it can actually be used to generate JSON objects as well, and then used in that way. Kind of more advanced way of doing it, perhaps. Maybe a later session for that. But in any case, template literal is a super flexible way of quickly making format changes that can be used for pretty much everything, right? HTML rendering, it's a template, right? So HTML rendering, CLI configuration changes, as well as in this case, just doing formatting for Slack. Okay, so let's move on. Now let's start building some stuff from the ground up. So a lot of sometimes string manipulation is kind of like like people scratch their head, like, okay, so I have a string, like in our first example, right? We got an IP address that wasn't quite in the right format. We had to do some string manipulation. Sometimes when you look at the features and functions of string, so string manipulation happens a lot, then there are a lot of different ways to do it. And depending on your background, depending on what the string looks like, there could be several methodologies to use for string manipulation and extraction. I'll cover just a few of them here. The right answer is going to depend. So again, what does the data look like? Is the data consistent? Your string manipulation and techniques like regular expression, which we'll talk about and show you here in a minute. If you're a regular expression, guru, then that might be your go-to. But if if you're not, maybe some of the other methods are better for you. So in this case, our example here is we're just going to create. We've got an input of a full name like John Smith and an employee number. We won't be using it, but we'll be using the name. So let's say we want to break up that name somehow, right? In this case, we want to get the last name, right? So what was one of the first things we did with string manipulation was the split command. We used that already once, so we can also see it working here. So if I drag split from here, oops, it's going to ask for a few parameters. Recall, it's going to need an input string to split. So that's going to map from our full name into here, and then it's going to need a separator. So in this case, our example data is first name space last name. So our separator is going to be a space. We know that the way this works now, we can see the return is going to return an array. So it's actually going to create based off of that separator. In this case, if the format is first name space last name, then it's going to give us two elements of an array. So if we want to get the last name, then we need to get the second element. In order to extract that element, if we go to array and we use getIndex. So now I'll drag that in here, and now the source, the output of the split becomes the array source for the getIndex method. And of course, this becomes 1 because that's the second element. And the output here is going to be a string, and I've already set up the outgoing variable for that. So with that, we should be able to run and see that this is one method of using to generate the data we need from a string. So we've extracted part of that string. So that's one way to do it. That's useful and helpful if you know that there's a separator that's always part of the format. So again, that / in the net mask coming from NetBox, that's consistent. So we can use this methodology, and this might be the simplest and easiest way to do it. There are other ways to do it. So the second method we could do it is using something called slice. So again, if we go down to here and we use the slice method, we'll see a couple things here. I get the some of the tooltips here for help, but having used this before, I know we still need a string input, right? So in this case, that will come from full name. So this is the string we're going to slice, but then it's asking us for an index number. And what this is at what character index or what character position in this particular string do you want to slice? Okay, so we've had to generate that now because it could be different. In this case, the first name is John. The next, so that's 4 characters. The next character is the 5th one, which is space. But if it was Robert, if it was Richard, that would be different. So there's a way to also generate that particular index number, and this is the way you'd want to do it because you never know what that first name is going to be. It could be a variable, variable length. So we could also use index of, let's see. It's not the one I'm looking for. String. That's the one. There we go. So I can get index of, and this is going to tell me which index that we're going that a particular character is found at. Let me move this out a bit. I'll need a little room here. So in this case, what's our search value? It's going to be space, and then that should return a number. And now this number can be used here as the index number to begin with, and then we should be able to output that now. So that meets the requirements that that particular method has. Let's save it and take a look. We can run it, and it does return Smith, but actually here we've got a space. There's a couple of ways we could take care of that. So coming from the index of into slice begins, but it begins at a space, and we don't want the space. We want to skip the space. So really, the value of index of needs to be incremented by 1 to skip the space. So whatever the index number the space is at, we want the one after it. So when we see those kind of things, and then delete that for some reason. But we can do it this way. Then we can use, let's see, a little bit of math. So since this is a number coming in, we can use the add method to increment the number from to +1. So since this is an add method, we tell it how many to add, in this case, +1. And then we can drag back our slice. And now we get whatever that value of the string was, or the number where the space appeared in the string. We're incrementing by 1 to skip the space. That becomes our begin index. Now we need the string as the source. So now that should skip the space. And now we map it back to slice name. And if we run this again, there we go. So our second method of extracting that was using slice and index of along with add to kind of skip the space. There's other ways to do this as well, and we'll see one of those in a moment. But yeah, that's another method. So here's a third method. In this method, we are going to use regular expression. So under cursor back here, under string, I'm sorry, under regular expression, we have an exec method here. In this case, we want to map the source string to here, and now we get to define the regular expression. Now, I'm going to be honest with you, I am not a guru at regular expression. I am very poor at it, but let me show you a half attempt at using regular expression. So I know if I do something like this, it should at least pick up everything from the space. I'm doing space, 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 like a white space, dot, and then a star. This should pick up, it should start the extraction at the space character and then give me everything after that. It's again, it's returning an array. So this could potentially be more than one. But in this case, we only really want the first index of the array. So we can also use here, get index. And if I pass the output of that array to there, the first element of the array, index 0, should give us what we want. And then that should output the string for a regular expression. And now if I run it, aha, but kind of the same problem. The regular expression picks up the space because that's where it started from. Now, if you're in a regular expression guru, you're probably shouting right now, this is how you do it. I'm going to show you, not being a regular expression guru, I'm going to show you another method that it can be done. Weird. Let's see. We'll do the get index in a minute. Let me take care of that. So we'll add the get index again. And then we will also do a trim. So if I go here, we'll rebuild that. Index 0. And then back to string, I can do a trim start. This will remove white space. Again, okay, I know I'm not a regex master, admittedly, but I'm showing you different techniques. So now that should take care of our little space problem there. And now we've got 3 different methods using 3 different ways of string manipulation based off of your previous experience, what the data looks like coming in the format that it's in. And again, there are multiple ways to probably accomplish this as well, but showing you some of those ways. All right, finally, as we're rounding the corner here, let's get to the final section here where we'll talk about conditions and conditionals. Conditional is the ability to test for a particular condition and go down a specific path. So earlier we talked about the CIDR and NetMask mapping. How do we translate CIDR to NetMask in an automation, not going to a website and looking up a chart, but inside of an automation. If I'm doing something on a Cisco iOS device, it expresses NetMask one way. If I'm on a Junos device, it expresses NetMask in another way. So this is always something to look at. So let's take a look at some ways we can do this using conditionals. So the way we typically have done conditionals, because these features were available, is we use something called a ternary. And I usually use it with an equality. And I'll show you how those work together. So we can drop an equality here, ternary here, and we can say CIDR as a parameter here. We're looking for an equals. If it's equal to 24, that's going to return a true or a false so that we can map that to a condition. If it's true, then I can return a string that references the net mask, right? If it's false, well, might be a bit of a limitation in that because there could be multiple net mask values here. But in this case, all we can really do is say, not 24. And then mapping that output should at least give us the ability to test for a single condition. So in this case, ternary net mask, since we specified 24, it returned true as the test. And then because it's true, it returned back that. If I did a 30, rerun it again, it's going to say not 24. So that you'll find that particular conditional available in all of our platforms. But I'm using version 22.1 of this particular demo of our IAP platform, which gives us some additional conditionals. So that's one of them you can always see. One of the other conditionals that we have is the switch statement. So the switch statement gives us some more flexibility in creating these kind of multi-path, not just one or two paths, but multi-path conditionals. So again, I can take my value here and feed it in as the input to a switch, and a switch will actually compare. We can have multiple comparisons going on, as well as a fallout default if a comparison is not made from the list. So in this case, what I want to do is I want to create some strings. So if I go to default, and you'll notice this new context handle that we've added as part of these new conditionals. So now it gives me a little more flexibility in what I can output as well. I can output new methods to do different manipulations or even more testing. So in this case, we'll keep it simple. If it's by default, if nothing matches our list of conditions, I'm just going to say, well, that needs to be a /32. But if the case here is 24, then I can map it to this new string. Gives me the right net mask. And here's the great thing. It's going to take one of these two paths. So I can now map both of these outputs to the output variable because it's going to take one of these paths based off the condition. And then we can do a third one right here. We're going to do a /30 on this one. And now if our conditional is a 30, we compared to as a CIDR, that'll be 255, 255, 255, 252. And we can also map that back into here. So now we can take one of three paths from this case statement, and we could continue on for all of the CIDR values if we wanted to. It would make it pretty long, but it would work. So if I run this as is, we'll see that since my input value was 24 coming in from here, it maps to the switch net mask of 24, which gives us the right value here. We could run it again, and I can change the data live here. So if I go 30, run it, you'll see that now it takes that next case, and I could run it one last time. And let's see, maybe my CIDR is something that doesn't appear. It would never happen. But it defaults to a net mask of our default, right? Because it didn't match any of the cases that we had listed. It's going to fall back to the default and give us a relatively safe /32 here. So that's why you could do it with the switch statement. It gives us a lot more flexibility in the 22.1 platform, above and beyond the equality and ternary. You can still use these. They're still useful, especially if you have limited paths that you want to test for, or limited conditions you want to test for, and limited paths. But switch gives you a little more flexibility. We also have the if else, which is very similar. We won't go into all the details here, but it's very similar to using the ternary as well. You test for a condition. If that condition, so you'd want to interface it with an equality of some sort, condition here, condition check, and then it gives you two paths out, but it gives you the context handles. So above and beyond the equality and ternary, this gives you the context handles like the switch statement does as well. And now you can build upon that because any of these methods have these context handles, and you can now create, even more advanced and complex transformations based off of these. And then finally, here's kind of a really interesting one to solve this little conundrum. I've used it in the past in demonstrations, but we have the ability to query a JSON object through the JSON method under Workflow Engine. In this case, we can use the CIDR. Well, we'll get to that in a minute. In this case, we can use this query. So what we can do is, if you're familiar with the idea of lookup tables, basically you can create a lookup table based off of a JSON object, because a JSON object defines a key and a value. And then we have the ability to query for a particular key and return the value. And in this case, it's kind of a lookup table, right? We reference these charts all the time as network engineers, but you can actually embed them into your data transformation. So in this case, I've got a lookup table to go from dotted quad notation to CIDR, and then a CIDR to dotted quad. And this is one we'll use for here. And we can use this query to do that. So my object now, just as long as it's formatted as a JSON object, I can paste into here. My query is a string. So I do need to do something, because remember, this is a CIDR is defined as an integer. So now I can do number to string. So I have to convert that type. So now I can map my number. It's going to turn it into a string that now becomes the query string for this particular, the query for this particular method. And now that's what that should do. It should say whatever that CIDR is set to, it's passed from our data source, converted into a string, passed to the query. So now that can query my lookup table, which is formatted as a JSON object. And now the output of that should be the value of that particular CIDR value in the dotted quad notation, because that's going to be the value for that particular key. So now if I run this, let's see here. Must have done something incorrect. ToString. Oh, I see why. Turn it into an actual CIDR mask that we would run into. Okay, so you see I changed the CIDR number that's input from the source to 24, and now it's pulling the right, it's doing the right lookup. And again, if I do a CIDR of 30, it should give me my 252, and it does even on both of these, both of these cases. And then if I run it again with a 32, we get the net mask from that query as well. So that's using a JSON object as kind of a lookup table to solve problems like converting data, subnet data, but this could be applicable to all kinds of different ways to manipulate lookup data. So with that, I know we're at the top of the hour, and I want to thank you so much. Hopefully this was helpful. I know when you say advanced, it's somewhat relative because it depends on where you're at. But if you're just starting into the platform, or you've never even looked at our platform before, hopefully this gives you an idea of what a transformation is, how it's useful, how it's even necessary, how it can be reusable, and then all the flexibility you have to build these things so that they can be used in your automations, especially with automations between network and systems that kind of operate together all the time in your automations. That's how they become reusable. And if you are coming from a background in writing code, then a lot of this should look very, very, very similar to you. Hopefully you see the ability to not only create these things, but the reusability becomes important. And the idea that making changes to the incoming schema is very, very simple and straightforward. so that even with systems change over time, maybe their API changes or their data format changes, maintaining these kinds of data transformation assets becomes a little bit easier for you than trying to maintain it in code. And maybe that's something you can also take a look at, as well as leveraging all the different methods to do data transformations themselves. So hopefully this was helpful. We want to thank you very much, and we look forward to seeing you in the next webinar. Bye-bye.